Alright, design in the software process. Let me tell you something I learned the hard way after many years in software. When we build a software, we are not just typing code randomly. Software is built by following a process. And a process is simply a set of steps that helps us go from a problem to a solution. Think of it like this. If you are sick, you do not randomly eat medicine. You first understand the problem, then decide the treatment, and only then you take action. Software works the same way. Every piece of software exists because there is a problem. For example, a company cannot track sales. A user wants to book tickets online. School wants to manage students. So if you do not understand the problem clearly, you cannot build the right solution. So this is where requirements come from. Requirements answer simple questions. What is the user trying to do? What should the system allow? What should it not allow? So skipping this step is like building a house without asking how many rooms are needed. And you start designing and building a house like this way. So the client won't accept that. So once we understand the requirements, we do not jump into coding directly. In fact, we design, and there are two types of design. The one is conceptual design and the other one is technical design. In conceptual design, we just clarify our concept, and for that purpose we can use CRC cards where we identify different classes and the relationship between the classes and also the responsibilities of each class. And in technical design, we draw some diagrams like UML class diagram, activity diagram, state machine diagram. So later on in the course, both of them we will be using. For conceptual design, we will be using CRC cards, and while for technical design, we'll be using UML class diagrams. It's like you're building a house. So first you draw a floor plan, electrical wiring, plumbing, and then you start building a house. So by doing this, you can actually save your money, your time. Use them to build working software implementation. So after the design is completed, only then we can start building the software. We can start coding. And once the software is built, it must also pass the testing. Now what happens in testing? Testing simply answer the question like, does the software work as expected? Is it secure? Is it fast? Does it break when user do something unexpected? So these are some sort of questions which is usually answered in the testing phase of software system. So this cycle is repeated for each set of requirements until a complete solution is created. So that's how software system is built. Many students think that they should jump to the code right away after the requirements, but it's not like this. You have to properly design it. So that's why I gave you a lecture on the design as well, that where the design fits in software process. So it is a separate phase in the whole process of software development. So yes, this is important, because if you want to build a software system and you want to scale it, make it secure, and you want to save money, so you cannot skip the design phase of the software system. Alright, design in the software process continued. One of the biggest mistakes I see in software projects is not lack of skills, it's lack of patience. And it is very important to allot time for requirements and design. Not because they will be perfect, but because even imperfect clarity is better than blind coding. In the real world, requirements are never perfectly established, and it's okay. What matters is that we slow down enough to think before we build. And here is the hard truth. Coding relies on assumptions. Every line of code assumes this is what the user wants, this is how the system will behave, this is how data will flow. So once coding begins, changing those assumptions becomes expensive and painful. It's like pouring concrete. You cannot easily move the walls. So this is why requirements and design exist. They force us to question assumptions, clarify understanding, reduce uncertainty, and they help ensure we are building the right product, not just a working product. A well-known survey by Standish Group shows that around 31% of projects fail due to poor requirement planning. Not bad coding, not bad developers, but due to bad planning. Jumping straight into the implementation feels fast, but it is one of the leading causes of project failure. You move quickly at first, then spend months fixing the wrong thing, and this is where mindset matters. Think like an architect, not just a coder. An architect thinks about the structure, how parts fit together, and the behavior, like how the system acts over time. That is what design work really is. Design is not decoration. Design is outlining a solution. Sometimes that includes exploring alternatives, comparing approaches, choosing the safest path forward. So remember, good software is built by people who think before they type.
Thank you so much for watching this. Before you go, please don't forget to subscribe to my YouTube channel and turn on the notification bell so you never miss any of my upcoming videos. I regularly share valuable lessons, practical tips, and step-by-step tutorials to help you improve and grow. And if you are serious about mastering software design and architecture and want a complete structured learning experience, so I have created a full course that includes detailed lessons, assignments, quizzes, and downloadable workbooks to help you practice and apply what you learn. So if that sounds helpful, just check the link in the description below and enroll in the course today. I would love to see you inside and support you on your learning journey.